Okay, so we are going to work on this one. It's series. And we have to find CT first of all. 1 over CT equals 1 over 2 and 1 over 3. Common denominator 3/6. 6 is a common denominator. 2/6. So that's 5/6. Now before I got to flip it over, so CT is going to be 6 over 5, which is 1.2 microfarads. And then QT equals CT/VT. So 1.2 microfarads times 500 volts, 600 microcoulombs. And that's, Q1 into Q2. Now V1 is Q1 over C1, which is 600 microcoulombs. Over, let's see, 2 microfarads. So that's 300 volts. The other one better be 200 volts, so we're going to see Q2 over C2, 600 microcoulombs, because they're in series. The charge has to stay the same, over 3 microfarads. There we go, 200 volts. Yeah, we're on our game. Now we need the energy. So energy 1 is 1/2 C1, which is 2, times V1 squared, which is 300. So that's 90,000 times 2 is 180,000 divided by 2 is 90,000. But I have a micro in there, so I have to deal with that. Don't forget to deal with it. So I'm going to wind up with 900,000. Let me check that again. That's going to be 90,000. Half of 2 is 1. So that's 90,000 microfarads. Or not microjoules, sorry. Or if you wanted to, you could just express it as 0.09 joules. Same thing. Then I have to do E2, but E2 is a 3 microfarad, so I'm going to go in here and change that. Getting lazy here. Kind of tired on a Friday evening. So half of 3 is 1.5. The voltage, however, is 300. Nope. How about 200? Square 200, and I think you're going to get 40,000. So that's going to be 60,000 right there. And 60,000 is the same thing as 60,000 microjoules, or that doesn't look very good, 0.06 joules. There we go. So there's number 1. Yay! Let's move on to number 2. So I'm going to scoot on down. And number 2, I have 2 of them in parallel. So if I have 2 of them in parallel, I have to do 5 plus 10 is 15, so CT is 15 picofarads. Pico is 10 to the minus 12. Yeah, you need to know that. QT is CT/VT. CT/VT. So that's 15 picofarads times 1,000 volts. So because I can be a little bit lazy and still be correct, I'm going to call it 15,000 picocoulombs. Don't forget the pico, though. Now, this does not equal Q1 and Q2 because we're not in series, we're in parallel. But the voltage is 1,000 and 1,000. So that was easy. So Q1 is 5 picofarads times 1,000 volts, which is 5,000 picocoulombs. And then Q2 is 10 picofarads times 1,000 volts, which is 10,000 picocoulombs. Now I have energy to do. Let me fill this in. 5,000 picocoulombs and 10,000 picocoulombs. Now I have energy. Energy 1 is 1/2 C V squared. So if I square 1,000, I'm going to have a 1 followed by 6 zeros. That's a million. And then I'm going to multiply it by 5 picofarads and divide by 2. And when I did that, I got 2.5 microjoules. And the other one is 10 picofarads, so it should have twice as much energy, 5 microjoules. Check your math. It should work just fine. All right, let's go on to our next one. Okay, so on our next one we have this little rascal in a combination circuit. So I know that the voltage from A to B is 24 volts. That's like having a battery there. These are in parallel, so I can get rid of them by replacing them with the 6 microfarad, because 2 plus 4 is 6. So then I have 1 over 3, 1 over 6, 1 over 2. So CT is 1 microfarad. All right, that's great, Miss Walker. Now what are we going to do? Well, we really have a 3, a 6, and a lovely 2, and they're all in series connected by a 24-volt battery. So I know that the charge here, here, and here is the same, and it's equal to QT. Well, QT is CTVT. So 1 microfarad times 24 volts is 24 microcoulombs. Now I have to be careful. Oops. These two are going to add up to 24. But their voltages will be the same, so let's go back and play with that in a minute. Well, B1 is Q1 over C1. So 24 microcoulombs over 3 microfarads is 8 volts. 24 microcoulombs over 2 microfarads is 12 volts. 12 and 8 is 20. I only have 24 to start out with, so it tells me this has to be 4 volts on each of these. So if that's true, then C1V1, sorry, C2V2, so that's 2 microfarads times, 2 microfarads times 4 volts is 8 microcoulombs. And then 4 volts times 4 microfarads is 16 microcoulombs. And again, this and this have to add up to 24. They do. Life is great. All right, let's see if we can finish up this last one and wrap it up. All right, we have a bunch of parallels, but then we have this series. So I'm going to say 1 over 24 and 1 over 8 is 1 over 24 plus 3 over 24. Oops, 24, which is 4 over 24. So CT is 24 over 4, or 6 microcoulombs. So that whole group can be replaced with a 6 microfarad, wake up, Miss Walker, microfarad capacitor. So, got that. Now let's go back and play. Well, what I know is that this one has to have 36 volts. This one has to have 36 volts. And these are going to add up to 36 volts if I know what I'm doing. Well, when I look at it, if I know the voltage and the capacitance, I can get Q1. That's a piece of cake. So Q1 equals C1V1. C1 was 4. V1 was 36. 144 microcoulombs. This one has half of the capacitance, so it should have half of the charge. But we could check it. 2 microfarads times 36 volts. And we get 72, so that's great. Now these are in series, so their charge is going to be the same, but I don't know what the charge is. So Q3 equals Q4 equals, well, we said that was 6 microfarads. And we said the total voltage there was 36 volts. So that's 216 microcoulombs if I did my math right. So 216 microcoulombs over 24 microfarads. Looks like that's 9 volts. And then 216 over 8 is, let's see, 27. So that should be fun. I think I've filled it all in, haven't I? All right, I'm going to hush. You have a great weekend. Please study. Please study.